Okay. Just in case you're watching this live stream, I'm still trying to let some people know that we're going live. Hopefully there are some people who are going to benefit from this. Get shareable link. Okay, I just want to share this on my Facebook. Okay, so as soon as I'm done with that, we can begin with this. Okay, so we are going to begin exactly at 8 o'clock, right? So we're gonna start with the question that's showing on the screen, and then we'll take it from there. Okay. Okay. Okay, it's exactly 8:30. I think it's the right time to begin with the discussion. Okay. So okay. So when you're given a question like this, there are two things that are important to understand. You need to understand how to treat like maybe variables that have the same exponent, or numbers that have the same exponent. Okay, by using the line two variables that have the same base, we simply add the exponents. So in this case, the first thing that you need to do is to decide how to treat the numbers that you're given. You see, you are given a number 8, and on one side they've got 2 8s on one side, and on the other side they have 2s. I think the best way to deal with this is to first convert the number 8 into 2 to exponent 3. Okay, so what I mean is that 8 is equals to 2 to the power 3. Okay, let me improve my drawing tablet. I think the ink is not doing justice, right? So let me try to change that. Okay. Okay, let's just delete this. Okay, what's happening? Okay, so in this case, okay, so we know that the number, the number 8 is equals to 2 to the power 3. Okay, so if we can convert both this 8 to 2 to the power 3, on this side we're gonna be left with 2 to the power 3, and then this, all this to the power a, right? And then if you have something like this, you simply multiply these two exponents. So this will be 2 to the power 3a. Okay, and then we also have to convert this one into a number 2 to exponent 3. Okay, so we're converting this 8 to 2 to the power 3. So in that case, we're gonna have 2 to the power 3, and then we'll move this one. So this 2 to the power 3 is actually our 8. We're converting this 8 to 2 to the power 3, right? And then we'll still keep the 4a. So we're gonna have 4a. Okay, then we multiply these exponents, which this one will give us 3 times 4 is 12. Then you have 12a, right? So then on this side, I'm just simplifying this so that you'll be able to see what's gonna happen with these two. So in that side, we're gonna have, I'm focusing on these two. You're gonna have 2 3a to the power 3a multiply by this one. This is 2 to the power 12a. You see, so this, I'm taking this to here, right? So what about the other side? Okay, so this will be something like this. Okay, if you look at the other side, everything has a base of 2, so I think it's just straightforward. Okay, we're gonna deal with this. Then you have this here, and then this is 2 to the power 3a multiply by 2 to the power 3a minus 6. Okay, the rule says when multiplying powers of the same base, you simply add the exponents, right? Okay, so in this case you can see the bases are the same, so we're multiplying these two, so we simply add the exponents. Okay, when you add 3a plus 12a, you're gonna have, let me just write that first. So this will be 3a plus 12a. Okay, 3a plus 12a, this will, okay, so since these two variables are the same, then they are actually like terms, right? If they are like terms, you simply add them. So 3a plus 12a, this will be equals to 15a. Okay, this then becomes 2 to the power 15a. Okay, we should not forget that we also have this side, right? So we're gonna divide this, and we use the same rule. When multiplying powers of the same base, we simply add the exponents. So these bases are the same, they both have 2 as their base. Then you're gonna write that 2 here, and then you simply add the exponents. Here you're gonna have 3a plus 3a minus 6, right? Minus 6. 3 plus 3, since these are the like terms, 3 plus 3, this will be 6. Then we're gonna divide this by, okay, you divide these two by what? By this, the answer to this one. So the answer here is 3a plus 3a, this is 6a. And then since we don't have like constants here, so we cannot add or subtract anything from this 6, so we take it as it is. Then it's minus 6. Okay, then what happens when you have division? Okay, so if you're dividing, if the bases are the same and you're dividing, you don't, instead of adding the exponents, you subtract from the exponents. You subtract the exponent. So this will become 12 15a minus. Why are we putting minus now? It's because here there is a division sign. If it was a multiplication sign, we'll put plus here instead of minus. So we're gonna minus all from this, the whole of this. So it's better you put that in brackets so that you don't make mistakes. This becomes 6a minus 6. So now we need to take out the brackets, right? Then you're gonna have your 12, 15a. I'm taking this from here, minus, okay? To take out the bracket, it's like you have minus 1 here, right? You take it as if you have minus 1. Then you're gonna say minus times minus 1 times 6a, then it becomes 6a, right? 6a. Then minus 1 times this one, it becomes positive 6. Okay, and then now you see 15a and 6a are like terms. What do you do? No, it's not 12, this one. Okay, it's 2. Then what do you do? Then you simply subtract them. 15 minus 6, then that becomes 9. Then you have your 9a. Okay, 9a plus 6. Okay, 9a plus 6. Okay, so this screenshot, I took this screenshot before they removed this one. So if you look at the current solutions, you'll see that there is 9a plus 6, which is the correct answer. Okay, so we're done now with number 6. Okay, we are done now with number 6. So which other okay, let me take a 2 minutes break to respond to some text messages on my YouTube. Okay, so yeah, how do you share this? Oh, so guys, this is actually my first live session, so some of these things are really new to me, so I don't know how to okay, anyways, okay, hey, can you share the link? Okay, let me respond to this one. Okay, where is the link? Okay, so let's move on to the next problem. Okay, I haven't decided which problem to do, but yeah, let me just pick one. Okay. Okay, let's pick a problem. Let's see, I'm looking for, okay. Okay, what problem should we choose? Okay, let's get rid of this one, delete this, delete. Okay, let's delete all of this. Damn, why is that? Okay. Okay, so okay, so let me choose another problem, then we can decide. Okay. We're not gonna do that one. That one is too easy. We're not gonna do that one. We can do this one, but let's see. I just need something. Okay. Okay, now let's do this one. This is number 11. Okay, number 11. Okay, so that is number 11. Okay. Okay. So this question states that let A be an even integer number, B be an odd integer number, and C be an integer number. Which of the following statements is not true? Okay, so first of all, you need to understand what they mean by integer. What is an integer? Okay, now let's even go further than that. Okay, what is an even number? Okay, so when we talk of even numbers, we talk of numbers like which, when divided by 2, do not have a remainder. So this can be 2, 4, 6, 8, 10, and so on. If you divide these numbers by 2, there's no remainder. Okay. What about odd numbers? When we referring to odd numbers, we're talking about 1, 3, 5, 7, 9, and so on. So if you divide these numbers by 2, you'll get it like a remainder. For example, if you divide 3 by 2, you get okay. So you don't get a whole number, eh? Yeah. Okay. So enough about that. So how do you approach this problem? So ideally, what I will suggest you do is that you just pick. Remember, you're given A and B. A and B can be any number, so you can just say let A equals to 2. Okay. Oh, sorry. Let A equals 2. Why am I choosing? Oh man. Okay. Let me use this thing. Okay, why am I choosing A to be 2? Because 2 is an integer, and they told us that this can be, let A be an integer, so it can be any integer. You can choose any integer, but I'm just doing this to show that if you're choosing numbers, it becomes a little bit more easier. Okay, a little bit easier to solve. Okay, let's let A equals 2, and then we let B equal 3. Okay, so let's evaluate these statements. They say if A times B equals to C, then C is even integer. Okay, let's evaluate that. If our A is equals to 2 and our B is equals to 3, then the answer is an even integer. Let's try that. 2 multiplied by 3, okay, we get 6, and we know 6 is actually an even number, right? And then here they told us that it has to be an even integer. This means this one is correct. So okay, that's not our answer, because the answer, we are looking for a statement that is not true. Okay, then the second one, they say if A plus B equals C, then C is odd integer. Let's try that. 2 plus 3 gives us what? 5. And 5 is actually an odd number, right? Okay, then this one is also true. You can use any of the you could have used any of these numbers. You don't necessarily have to use 2, as long as you choose an even number for your A and an integer for what? For B, right? An even number for A and an odd number for B. Okay. Yeah, okay, so we're done with that one. Let's evaluate statement number 3. Statement number 3 says that if B times B equals to C, then C is even integer. Let's try that. Okay, b times b, our b is 3. 3 times 3 equals 9. Is 9 an even number? No. 9 is not an even number. 9 is an odd number. So this statement is not true. Okay, so we know that our answer here is correct. It's actually this one. Okay, we can even evaluate the last one too, just for educational purposes. Okay, if b plus b equals to c, then c is even integer. Okay, b plus b, this is 3 plus 3, and then this is equals to 6, and 6 is what? Is an even number. Therefore that one is also correct. So the only statement that is not correct in this case is this one. Okay. Ooh. Okay, why is this not available then? Oh shit. What happened? Okay, it seems like there's something wrong with our live streaming session. What's happening? Why is it saying that it's not working? Okay, I am not sure. I hope you guys can still access this. Okay, I don't know what's happening. Okay, let's see. Is that even still going live? Okay, I have no idea what's happening. Okay. I hope. Let me try here. Sorry guys, if you are able to access the video, I'm sorry, it seems like some people are struggling to watch it, so I'm trying to check to find out if there's a problem or what. Access the video, I'm sorry, it seems like some people are struggling to watch it, so I'm trying to check to find out if there's a problem or what. Okay, I think we're still fine. Okay, sorry about that minor disturbance. I don't know what happened. Okay, so let's move on to the next question. Let me choose another question that I think we should discuss. Okay, I think we should look at the last one. Is it or no? Let's start with number 19. I think. Yeah, this one. Let's start with the last one, okay? With number 19, I mean. Okay, so let's delete this and also remove this, okay? And also remove this, okay? So yeah, let's okay, okay, so this question, okay, 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 my drawing tablet has determined. Okay, so this question, they state that two linear functions a and b described by y equals to f of x equals to ax plus b. For function a, the y-intercept value is -2. It's -2, and the ratio of the change in y to change of x values is 4. Okay, so with this one you are already given some information, right? So you know that the equation of a straight line has this standard formula, right? So you know that your straight line is y equals to ax plus b. Okay, they gave us information that the y-intercept value is -2, right? So we already have a point. We know that at your y-intercept, our x value is equals to 0. So we have one point. The point is 0 and -2. And they also tell us that the change in y values 2 or 2, okay, the change in y values to change of x values is 4. That means our gradient or your slope, which is given by this equation, which is equals to change in y divided by x2 minus x1. This is your change in x. So for mathematicians, you could have written it like this, over change in x. Okay, but that's for another day. Okay, so we are also given the value for the change in y over change in x, and they told us that it is equals to 4, right? So we know the equation for b. Your b equation for this is a, the equation for a is given by y equals to, we know that the gradient is 4, and then 4x okay, plus b. So to determine b, you have to use this point to determine b, and then this will be substitute for y, this value will have -2 equals to 4 to the power 0, no, not to the power 0, and you substitute the value of x, which is 0, then plus b. Therefore we know that the value of b equals to -2. Then your equation is given as follows. This is 4x minus 2. Okay, this is the equation for b. So what about the equation for, I keep on saying b, that's the equation for a. Okay, then for b we are given 2 points, right? We are given 2 points. They just want to test if you can calculate the gradient. You are given this one, this is your point 1, and then this is point 2. So you have to determine the gradient for b, right? So let me just write it here. M equals the change in y over the change in x. Okay, m equals to change in y over change in x in this case. So this is our second point. So if it's your second point, that's gonna be your y2. So second point, this is x, this is y. It's always like this. When you are given coordinates, x is the one on your left and y is the one on the right. So we're gonna take this one, this is 0 minus, this minus comes from the equation itself, minus, and then we minusing what? We minusing -3. We minusing -3, and then this is, I'm taking the y values. I'm determining the difference between the y values, right? And then here at the bottom you're gonna have the value from point 2, which is 1.5 minus this 0. Okay, this becomes positive what? Positive 3. divide by 1.5, and then this gives us a gradient of 2. Okay, so the slope for function b is 2. Okay, then once you have this, you can determine the equation for function b as well. So you just take one of the 2 points. You can take any of the two. So, and then you substitute just like we did here. The standard formula is equals to ax plus b. We know that our gradient is 2, so we substitute 2 instead of a, and then now we have this equals to what? Equals to y. And then we take 1 point, any of the 2 points. Let's take this 3. Let's take 3 and 0 from here. Minus 3y is minus 3, and then equals to this 2 here, 2, and then we substitute the value of x. In this case it's also 0, and then this is a plus b. So we know that b equals to minus 3, and then if we have to substitute back to the standard equation so that we can have our function, we're going to have y equals to, the gradient is 2, and then we put x, then you subtract the minus 3. Okay, so now you have both equations, and then you can begin to answer the questions that are posed to you. Okay, so here what they're saying, okay, so here you need to, or they say in comparing the rate of change, which statements about the lines described by function a and function b is true? Okay, they want a statement that is true, right? The first statement says the lines described by function a and function b have the same slope. Okay, what is the slope? The slope is your gradient. To determine it, to determine if they had the same slope, this number here will be the same. Is this number the same? No, this is our slope. This for function a is 4, for function b it's what? It's 2. So this one is incorrect. Okay, the lines described by function a and function b both have negative slope. Is this negative? Is this negative? No. So this one is also incorrect. The lines described by function, the line described by function a has a greater slope than the line described by b. Which one is described by a? Is this one. Is 4 greater than 2? Yes. Okay, 4 is greater than 2. So this one is correct. Okay, so let's even read the last one just for academic purposes. The line described by function a has a negative slope, and the line described by function b has a positive slope. No, that is not true. They both have positive slope. Okay, so we have our answer for this question. So yeah, I think we are in the clear. Okay, so I hope everyone is still following, right? But let me go to the comment section. It's still quiet. I hope people are able to access the live stream anyways. Let's see. It's still okay. So yeah, okay, we're done with this question. Let's just erase this. Okay, I need to find a better way of erasing. My tablet. Don't disappoint me, tablet. You did exactly what I asked you not to do. Can we just delete this thing? Control A. Oh, should have used that. Okay. Next time I'm just gonna use Control A and delete. Okay. So okay, so far so good. So let's move on to question number 20. Let's see, question 20. Okay, I'm gonna put it here. Okay, so but this one, if you were able to do the last one, I don't think you'll have any problems with this one. Okay, so okay, what is the question saying? Okay. Oh man, I need to see the instructions. Okay, I think it's fine now. Okay, tablet, don't disappoint me. Okay, the following table shows the points through which the linear function y equals to f of x equals to ax plus b passes. Okay, the straight line that has a greater slope and a greater y-intercept than the straight line described by the line function above. Okay, so before we can compare, okay, before we can determine which of these have a greater slope or a greater y-intercept, we need to have a function of our own, the one that we're going to use to compare. At the moment, we can't just go here and start comparing. So let's determine the equation of that particular straight line. So I'm not going to waste time here because we discussed this on the previous problem. So first thing, when you're dealing with a straight line, determine your gradient, which is your change in y over change in x, given by y2 minus y1 over x2 minus x1. You can choose any point here. If it's a straight line, doesn't matter which one. So when I say a point, I mean x and y coordinates. Okay, like any 2 points. So we're gonna take just want to make it simple for myself because I don't have a calculator. We're gonna take these two and these two. So this is gonna be our P1, this is gonna be our P2. That's gonna be our P2. Okay, so okay, from P2, what is the y value? It's 9. From P1, what's the y value? Minus 5. Okay, and then from x2 we have 1 minus 1. Okay, so this becomes, at the top we have 4, at the bottom, what is it? Okay, at the bottom we have 2. Okay, so if you have minus like this, it simply becomes like a plus, right? So this 4 divided by 2, it's 2. Okay, that is our m, that is our a in terms of how your general formula is given. Okay, so since we have that, my calculations are a mess. Okay, now we just have to substitute that into the general formula. That's 2x plus b. Okay, now we need to solve for b. Take any point. Okay, I'm gonna take this one, 5 minus, okay, 5, okay, minus 1 and 5. So our y value in that case is 5 equals to 2, and then we substitute the x value, which is minus 1 plus b. We are trying to solve for b. This is minus this becomes 5 equals to minus 2 plus b. Taking this to the other side becomes b equals to 7, right? Okay, so now we have b. So our formula is y equals to the gradient is 2x, and then what's the value of b? Plus 7. Okay, so looking at this function, okay, they say the straight line that has a greater slope and a greater y-intercept. Let's first look at the greater slope. When you talk about the slope, we're looking at this one. Okay, which one is a value that is greater than 2? The first one, no, it's not greater than 2. This one, okay, it is greater than 2. This one is greater than 2, and this one is greater than 2. Okay, so now we're looking at the one that has a greater intercept. So when we're talking of a y-intercept, we're looking at this value here. Now let's look at the function that has a value greater than 7, right? Greater than 7. Remember, your b is always your y-intercept in it, like, you know, if you're given a straight line like this, since this one is gonna be 0 anyways. So okay, so we're looking for a value that is greater than 7. Is this one greater than 7? No. Is this one greater than 7? No. Is this one greater than 7? Yes. Therefore, the correct answer for this problem is this one. Okay, is the last one. Okay, we're done with that one. We're done with that one. So let us just delete this. Control A, delete. Oh my man, should have done that long time ago. Okay, so yeah, okay. Which one am I gonna do now? Okay, I think I'm gonna do 2 more, and then I think I'll call it a night. So if you like to learn from, if you want us to teach you, you can go to kalitutors.co.za. we do have online classes which are only accessible to our subscribers. Okay, kalitutors.co.za. okay, let me choose another question that we can look at. Okay, another question that we can look at. I don't want a long one. We can do this one, we can do that one. Which one are we gonna do? Let's see. This one, I've already posted a video showing you how to do that one. Okay, but I feel like we shouldn't. Okay, yeah, let's do this one. Okay, so here I'm even lazy to go through the calculations, but I'll show you how to do it, right? So the question, okay, the question asks, okay, in the Cartesian plane below, determine the shortest distance from point A to point D if you have to go through either point B or point C. Okay, so they want to, okay, no man, we're not gonna use the picture itself. Okay, we're not gonna use the picture itself. Where is that? Okay, it's 17. So we're supposed to use this tool here. Okay. Okay, so here the only thing that we're supposed to do is to determine these distances. Okay, that one, or why do I have only like few questions to determine which one is actually longer between the two? This one is not supposed to go there. Okay, no. Oh, should have used. Oh, it's me who's supposed to use this, man. Okay, that's it. Okay, we need to find out which one is shorter between these two distances. So the only thing you can do is to calculate the distance here, the distance from here to here, and the distance from here to here, and then add those two distances, and then calculate the distance from here to here and the distance from here to here, and then you add those two distances, and then from there you can determine, you can tell us which one is shorter. How do you calculate the distance? Okay, so one thing that you need to know the points. You are given the coordinates. So here it's just you recognizing which one is x, which one is y. So here the coordinates here, our x value is 4, our y value is 3. Here our x value is 2, our y value is -2. Okay, here the values, the y value is 2, the x value is minus 2. I mean, this is minus 2, and then this is 2, right? Minus 2 and 2. This is minus 2. Minus 2, x is minus 2, and y is 2. And here they are both minus 4. Okay, minus 4, minus 4. Okay, how do you calculate? Oh man, why is it doing that? Okay, damn. Technology. Nah, but I'm gonna get used to it, eh? So sorry for that, guys. Sorry. Okay. So okay, let's get back to work. Let's get back to work. Let's make this one red again. I prefer red. Okay, then you just need the equation for the distances. To calculate the distance between 2 points, d is equals to, then this becomes your x2 minus x1, is it, square plus, okay, x2 minus, oh sorry, y2 minus y1 square. Okay, you have to do this. You have to calculate for this, you have to calculate the distance from here to here, and the distance from here to here. Okay, so when it's like this, it doesn't really matter which one is x1, which one is x2, because you're gonna square it, and then even if it was negative, it will become positive anyways. So you just determine the difference between the two. I'm not gonna do that. Let me just substitute 1 for you. So I'm gonna try to substitute for this here. So this is it will become something like this. Oh man, this tablet is misbehaving right now. Okay, or is it getting hotter? So what is x2? In this case, x2 is gonna be the negative 2 minus x1 is 4. Then you square that plus y2 is 2 minus what, 3. 2 minus 3, and then you square that. Then you're gonna get your answer. Okay, I don't have a calculator. Okay, let me find my calculator. Yeah. Okay, so let me calculate this. Okay, let me calculate this for you. Academic integrity, this is part of learning. This is learning. This is how you learn. Okay, so I can do this using my head, but I did enough mathematics at school to want to do that using my own head. Don't remember the last time I used this equation anyways. So that becomes 1. Okay, so this is okay, the answer to this is 6.083, is it? 3, yeah, but you could have just rounded to 2 decimal places. I'm just being crazy. So the distance here, the distance is 6.08. Okay, calculate the distance here, calculate the distance here between these 2 points, calculate the distance between these 2 points, and then add these 2, and then add these 2, and then you compare which one is shorter because that's what the question wants, right? Let's go back to the question. Okay, where is the question? Okay. Below, determine the shortest distance. Yeah, then you determine which one is shorter between the two. Don't be fooled. Some people look at it and think it's a kite. No, that's not true. These coordinates are not identical or symmetrical in a way. So if you look at this one, this is -4 and 4. This one is 4 and 3. If this was 4 and 4, the distances will be equal. So okay, thank you for joining us for to discuss maths. I just hope you'll subscribe to our channel, then we can learn in advance instead of giving you guys answers. Okay, ciao. Ciao, ciao. Oh man. No guys, it's late. Next time, if you want us to do some of the problems, you can join our online classes. We'll do all of them there. So I see Vuguzake says we should do 15 and 10. We've already done 15. Just check I've posted that video I think yesterday, but 15 it's too late, my bro, it's too late. But yeah, I'm sure which 15, I think, let's see, but I'm not gonna do it. I'm just looking at it. 15 or 10, which one did we do? Oh, we did 15 and then we didn't do 10, we didn't do 9, we didn't do these ones. Yeah, but I think they are simple. Join our online class next time. You'll be ready for the next assignment. Okay, thank you guys, good night.